ছবি না দেখালে বুঝবি না তোরা। So this is the structure of what your this thing will be. This, if you actually see this part, int argc, in character pointer argv. So what it does, actually this is basically what I'm actually doing is command line arguments. Okay, so this is, I'll start off from here. Okay, so command line arguments, what it does, it's something like this. Okay, just to note that these commands which I'm actually working, these commands what I'm actually showing, these are basically Unix commands. So ls command, which actually lists all the files and directories in the specific directory. So you all have ideas. How many of you do not have any idea what is a directory like and what is a file and any sort of thing? How many of you do not know that?
Sir,
Hello?
Jaina.
Okay, so let's go with this thing. Okay, so if I actually just to get hold of this thing. So this is what you see in directory, what you actually see in a Windows, right? That is basically a GUI version of the port format what we see as the command line interfaces. Okay, so in the command line interface there are two things what we have got. What we also have got basically a file. Okay, so the directories are actually all your folders in a very rudimentary sense. So in a rudimentary sense, all these directories what you actually see, these are actually all your all these folders what you see, these are actually directories. Okay, so in these directories I have, these are what we see to be as files. A directory can also have a and have many directories itself also, right? So if I actually see something like this, structure. So in a Unix system, right? In a Unix system, a directory is like something like this, right? So this is a root. I'm talking of the Unix. Okay, now the Windows is almost similar, but it does not have that many directories right now. Although the Windows 10 or present Windows 7, which is the present Windows, what is going on? Can anybody tell me what is the present Windows? I do not know what is the
10,
present.
sir, 10,
So
10.
Windows 10, sir.
10. So I believe so Windows 10, they also have basically, they are going into a structure like the Unix also, right? So the Unix directory system looks like this. There is something called a root. So this slash is basically the root, right? So if I have cd, if I go root, so if I see, so this is all the directories. So in technically, if I can also see just okay. Yeah, so you see all these things. So this is the root, you can see, right? So this is the root, and these are all my directories. So if you actually see, if you actually compare it with this line, with this line, you will see all this. So the blues are all your directories. So these turquoise colors are actually all your files. These are basically special files. All these also different files, right? So you can see I have got a bin, I have got a CD-ROM. So CD-ROM is somewhere over here. Then I have got a etc, that is the etc directory. Then I have got a lib, media and all these files. So now everything is a file in Unix. Everything is a file. Everything is a file. Even a printer is also a file. So it treats a printer also as a file. It treats a screen also as a file. This is the most fun part, right? This is a very, very interesting thing. So everything is actually a file. So if we actually see the directory structure, you see this is a root. I have got a bins. I've got a device. The dev is basically a device. Etc. The home. The home is a directory under which all your users basically rise. So my folder, my folder which I have got presently, this is basically, if I actually go to my home, so it is a home. Where is the home? Where is the home? Where is the home? Yeah, so this is a home. So I'm the only user over here. So once I get over here, you see I'm back to where I was. Right? So I can have directories under directories. I can have files under directories. So each of these folders in Unix has got different utilizations. Okay, so home has got all the users bit among them. So each of these homes have got their own rights and everything. This is basically the bin. The bin has got all the basic programs which you require. So ls being a command, right? So ls is actually again a command, right? But the command is actually again a program, which has been written in C, right? So all these programs are actually lies in bins. Then I have got a root, which is root directories, the person who is basically. Then I have got the devices. This device dev basically contains all the device informations of your system. etc has got a specific file which has got the password. So the thing is that until unless if I'm not a root, right? If I'm not a root user, or what you also say, the root is basically also said to be as a super user, right? SU, that is what you say. So if you're not a SU or the super user or the root, you will not be able to access basically all these files. So that is where when everybody says that Unix has got a very unique sort of a basically security system, it is only for these reasons. It is only for one of these main reasons are this. So you cannot basically, if you don't have a root password, you'll never be able to basically access. So temp is basically all the temporary files which are being kept over there. Okay, so coming back to my system is that I require to have basically, so I have got these stuff. So these are my directories. I can have lots of directories under them. So let's take what is, so if I have got a home, right? So these are my, so if I want to make a new directory, the main command is mkdir new dir. So you see, I have basically done something like this. So if I actually go over to my directory, so this is, you see, this a new folder has been created. So folders at one end is basically a directory and also a file. Okay, so why did I get into all these stuffs? Okay, so yes, the thing is that, okay, so so the thing is that basically I'm looking for, so I'm basically looking for commands. So ls is a command which actually shows you all the directories and all the files in there under a specific directory, so in which you are actually logged in. So my present working directory, that is a pwd, is this what we see as a present working directory, is this one. So is the full, this is the full path, this is what we say. So the path is /home/chintan/cpnp with a space and programs, right? So this is basically my full path. So my present working directory is this one, and all my commands, all the files under this thing has got what do you say? Has got all these sorts of files. So I want to see right now. I want to see in specific ways. So let's say for ls -a -al, say -l. You see, if I give -l, then my structure comes out something like this. Right. So -al if I give, so -al basically -a, that is all, and the all, and the L is basically the list, in the list format. So this is basically list format. So my extreme left hand side is basically, you can see this is basically RWX. So these are, I've got three sorts of users in Unix. One is yourself, one is a group user, and one is basically others, right? And this is the name which has been, so this green basically points out that this is an executable file, and these are basically all the files which you have got. Somebody did send me, Orgodip did send me basically a file of a program of, I believe so, on this thing. No, not matrix. There was a matrix one. Yeah, Kushal did send me a multiplication. Well, it was good, but then it was, as I was saying, it was not elegant enough. Okay, so these are all your files. Now, if you, so ls is a command, right? Ls is a command. So similarly, a dot out is also again a command, right? A dot out is also a command. So, but ls minus l if I give, so this thing, this is basically a parameter which I'm actually going to pass through this program. This is basically a command line program. This is what is basically I'm passing through the command line. So this is basically, this what you see is basically what we say as a command line interface. So this is my command line interface, or also to be said to be as a CLI. Right. So in the CLI, when I basically call for a program, I can also pass parameters through the program also. This sort of programming style is what we say to be as a command line programming. So command line programming, to actually implement a command line programming, what we require is basically the program has to basically, there's some parameters. So the parameters, what are they? So the parameters, what are there? They are basically all, is basically a character. It's a pointer to a character array. It's a character pointer arrays. Okay. So how does it look like? So let's say if my program name is echo, right? And I try to pass parameters like hello and a world over there. So what it will do is basically pass basically hello and world. So how does it actually look like? It looks like something like this. So this is basically my argv. So this is argv is basically this is a pointer to an array of pointers, array of character pointers. Please note. So this, you see that this point, the first pointer points to the first this thing. So it's the first pointer. It's always the program name, right? The second parameter is basically my parameters which I'm going to pass, and third and fourth and fifth. So it goes on printing as many number of parameters I have got, right? So how do I actually do this thing? So I'll just take this thing. If you actually see this program, so it has the total number of parameters over here, which is being passed with the program name. So if I do something to like this, so let's take, for example, if I just copy this one and just copy this thing and I just paste it over here. I want to know that how many number of basically my parameters which are passing. Okay, arguments. This is argc. Then let's start from basically start from this here, right? So what happens is basically if I actually compile this one, GCC, file.c a.out. So I just what I do is basically I just basically do not give any parameters. See what happens. So there is only one argument, and what is that? That is a dot a dot out. Right? If I want to pass my parameters now, hello world and everybody. Right? So it will be something like this. So what it does, it actually basically starts taking one parameter each. So what it does is basically do one, this is basically a string. Please note that this is always a character string. It will be a character string. So even if you want to pass numbers through a system, then what you require to you have to basically convert that number to a that string to a number, and then do something like this, right? So let's take, for example, if I want to add two numbers, right? So then so I'll assume now this is an assumption which I'm actually doing, right? So I already know that basically, I already know that the total number of arguments are what are there. So let's say I want to okay. So since I know, so let's do one thing. So let's make an array of. I want to basically convert all these numbers to these strings, which are these parameters, which are actually numbers, which I'm assuming they to be numbers, to basically convert it to be as a number. So let's say I'll assume that they're all floats. So since they are floats, so to actually now I do not know how many numbers they will be. The fun fact is that I do not know. So I can make a total array of all the numbers. Or let's say, for example, I want to basically allocate my this array dynamically. So the allocate will be basically an integer pointer. The array will be basically, it will be an array. It will be a pointer to a memory allocation. It will be, what I'll do is basically I'll allocate a memory of a certain length. Right, I'll allocate a memory of a certain length, and since it's a memory location, I'm going to keep that memory over there. So basically this will be an array is equal to int pointer malloc. Okay, I always get confused with my commands. Malloc. So malloc is basically, so there are two versions. There is one, you can basically work with a malloc, or but you can basically work with a calloc, right? So the malloc is basically takes the total size, and the calloc, it takes the first size and then the size of the parameter which I'm going to parse for. So let's say I'm going to show you both the things. It does the same stuff actually. Please note one thing: this two program, malloc and a calloc, it actually returns a void pointer. So why is it a void pointer? Because the program does not, it actually basically allocates a memory location, but it does not know what is basically going to store. It's just a memory location. So what I do is basically I basically mask it to say that I mask the void pointer to be as an integer pointer. So something like what we had done, something like int of a float. So if you remember, something like what we did was something int I. So sorry, something like float I. So what I did was basically I was masking I, which is an integer variable, to be as a float. So I'm doing the same stuff over here also. I'm going to do the same stuff over here. Okay, so my malloc is basically takes a total number of size. So this one will be C argc. So the total number of basically it actually passes the total number. So I don't require -1. So argc -1 multiplied by size of int. So this is the malloc is this thing. The calloc one will be integer pointer calloc argc -1 comma size of int. Okay, any questions till here? Any questions till here?
সিনট্যাক্সে malloc আর calloc এর মধ্যে কোনো ডিফারেন্স নেই syntax
Okay. There are basically there is an argument behind it, but it has not been still. But that actually depends to your operating system to operating system. There is an argument is that malloc, when it actually basically allocates the system, right? When it allocates the system, it actually makes that total area blank. So initialization is basically zeros, whereas calloc it does not do it. So this is the one of the arguments. This is one of the arguments. Okay, so I for myself basically what I do is basically I keep myself safe. So whenever I get these things, so I basically just convert this whole stuff again into what do you say, into initialize them with basically my this thing. What do you say? My what do you say? Your
zeros.
As zeros. Okay. So this one, then what I'll be requiring, since I'm going to pass 1, then I don't require this thing. So then this is basically becomes an array, right? So I -1 is equal to there is a command by the name of man a2f. So a2f, what it does is basically it basically takes a character pointer and it converts to a double, right? So okay, this was to be basically I was assuming that to be a okay. So this one will be a double. So this will be a double, and this one will be a double. This one will be a double. So temporarily this one will be also double. This one will be also a double. Right. So I'll be using the command of a2f, then argvi. Is it all right? Yeah. So a2f, what it does, you can see there is another command by basically man a2i. Man a2i. Right. So a2i basically there are two one. A2i basically converts to an int. A2l is basically long, and a2 tall is basically long int. Okay. So if you want to see what are all the commands. See, stdlib dot basically gives you all these commands over here. So alloc, srand, rand is basically a command which basically creates a random number, which gives you a random number. But then the random number is actually what we say to be as a pseudo random number. Okay, it's not an exact random number. Okay, so now so let's take for example what I do is basically let's do something like this. I want to see my, so this is percentage d, and this will be array I -1. So let's see what it will actually give me. Okay, there is something very important which you actually do before exiting the program. This is what you require to do. You require to free the idle location which you have basically created. Right? Why you have to do it is that basically when it allocates something, this is not what if you know Java. Java, this is a programming language which actually basically has got a it's got a system where it can reallocates or basically memory allocations by default. But unfortunately, C does not do it, or even C++. So when you are allocating a memory location, you have to delete that memory location. If you do not do it, then what will happen is that, let's say, for example, you run this program for about 10 times. So as usual, always there is some memory allocation is being kept, but it's not being freed. So the operating system does not know the memory allocation which are actually used, which has been basically allocated. Right, since it is not there, then what will happen is that after some time your memory will go out of memory, and your system will start to hang.
Sir, are you saying that memory leaks?
Yes.
Are you defining memory leaks?
Memory
Leaks.
memory leak matlab?
Leaks, sir. Leakage of memory.
Yeah, something like that. Yes, you actually basically refer to that something over there. Like this is basically what we say to be as memory leaks, right? So the thing will be GCC file.c. Sorry. Sorry. The program will be not there. It's already in strlib.h. Don't require this thing. Calloc will be basically man calloc. Okay, this is also in strlib.h, so we don't require to do it. So that's good enough. Okay. Okay, what was the problem? Percentage D calloc into size of double. Okay, this thing we have to do something like this. Not mask it. Should open that. Oh, sorry.
Sir, we multiplied memory size inside
No,
the math.
the spelling is wrong. Right, the spelling is wrong. And percentage D, this will be percentage F. Right. Now it should work. Okay. So I'll be passing a dot out. Say 1. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So total number of arguments is 13 because 13 this one which is actually being counted. Any questions here?
So can you please show the program?
Huh?
No, sir, nothing, sir.
हाँ actually show जा को. Actually go show जा.
Sir, one question.
Yeah.
Sir, when the program is terminated, all the memory is not deallocated on its own. We have to free.
No. C does not do that. C or basically C++ does not do that. That is something which Java does. Java is again a programming language. That is the one which it actually does.
Okay, sir.
Okay.
Sir,
So
what is the meaning of line number 14 at off?
at off is a, so this is basically what? This is a character. So I have to convert this character to a float. Yeah. Okay.
Okay.
This is basically an std.h. Okay. Look, these are actually only available in your, it's not available in C and for my Windows, unfortunately. It's all inbuilt in my Unix system. So I don't have to think about all my stuff. So. Okay. So coming back to right now, this thing. So the allocation of this memory is something like this. You see, this is again a two-dimensional array, which is actually character array, but the length of the things are not same. This is what we say also to be as a rugged array. RUGGED. This is also said to be as a rugged array. The arrays which we had actually basically seen where my integers were there, for my floats were there, or the initial ones which we had actually discussed in last classes, those were what we see as regular graphs, regular arrays. Regular arrays. Very, very symmetrical. So you see, this is not symmetrical. So this row, it has got 3 rows, but it does not have all the number of columns are not same. So you see, this one has got, this is the first column, this is the second column, this is the third column, this is the fourth column, this is the fifth column. But again, this one does not have a 6th column. Right? But this one has got a 6th column and 7th column. So this is what we say to be as a rugged array. This array, when you are basically passing a parameter through this thing, they are all characters. They are all character string. They are not only character, they are actually strings. You see, all of them ends with a /0. Okay. So what I'll do right now is that I'm going to pass these files. I'm going to pass some file name through my parameters, right? Through my parameters, and I'm going to print that file. That is the only thing that I'm going to do. Okay. Any question? So there are 2 sorts of files. File structures, what you can say. One is a structured file, and the other, this is one, and the 2 is the unstructured file. So what does a structured file looks like? So structure is basically what can be also said to be also as referred to as what we actually refer to be as a CSV file. CSV. So this is basically comma separated values. I believe so. V is for values, I believe so. I still remember. Okay, so what is the CSV file? What is the CSV file? So I have got some parameters. I have got some values which are actually separated by commas. So let's take for the 1, 2, 3, 4. There is an enter. Then again 2, 3, 4, 5. Then there is an enter. Then I have got a 5, 6, 7, 8. Right. So with an enter. So I have got, you can see they are basically all these numbers with a comma. right? And at the end of it is basically a line. So this is what we basically is what we see to be the structured file. It has got a specific structure. Maybe your first column, your first can be a string, then it can be a number. So this can be also something like this can also be there. So AA, then I have got basically, and it cannot, it's not necessarily it has to be separated by a comma also. It can be separated by a space also. So this is something like this 2, then 4.5, 4.6, then I have got BBB, then I have got 5 comma 2.3. So you see there is some structure. That is my first column is basically it's actually a string character. There's some set of characters. The second one is an integer, and third column is basically it's actually a what do you say? It's actually a what do you say? It's actually a float. Okay, so this is what we say has to be a structured file, and everything else is basically unstructured file. Everything else, right? So basically a text document, normal text document, that is a structured file. So maybe this whole thing what you actually see, this is actually a unstructured file, right? This is basically a structure because there is no format over here. You can see the top lines. Line number 1, there is no format. It's just a simple straight cut. There are some words. Then I have got some. This is basically not the structure. This is not like, it's nothing like that. It's nothing like that. Okay. So these are two ones. This is a structured file and it's an unstructured file. So
unstructured
huh?
Unstructured
এটা structured নয়
example data
তুই কোন যে কোনো টেক্সট ফাইল খোল না, টেক্সট ফাইল এটা একটা আনস্ট্রাকচার্ড ফাইল। কোন স্ট্রাকচার আছে এটা?
না নেই।
So this is also unstructured file, right? Even this one is also your C programs. If you actually see, this is also unstructured file. This is also unstructured file. Okay, the structure is basically it has got something over here. Okay. So what we will do is that there are two things what I'm going to do. Number one, I'm going to create a file, right? So a file is basically if you actually see a file, it has got it's basically a pointer, right? It's actually a pointer to a structure by the name of file, right? So it actually basically starts with file pointer fp. So file is the structure which refers that it will be a file, and pointer fp is basically it's a pointer to the file, As I was saying that since all my everything is a file in my Unix, even my standard input and my standard output, they are also files, right? So standard input, this is basically stdin. This is basically an input file. Then I have got a standard output. This is basically std out. Okay, so these are again also files. Files in Unix. So actually from these two words only, basically this has to actually come stdr.h. So it's the standard input and output. Okay. Okay, so where do I start from? Okay, what I'll do is basically I'll take up a simple program which is in my uh, which is in my this thing is in the book only. That is basically it's a error handling book topic. What I'll do is basically I'll assume that I'll take in two parameters, right? Two parameters through my arguments as an argument. One will be a standard input, one will be a standard output, right? But what will be copy that file into an output, right? And if there are no parameters given, then I'll assume that my outputs and inputs are basically they are same. Okay. Any question for that? Okay. So I require a file name, a program function file copy, which takes in two file pointers. fp read and sorry file pointer fp write. Okay. Okay. So there is another one fp. So this one will be fp read and fp write. Right. Okay. Okay, let's take another one program actually control. So this is basically file copy write dots. Okay, so where is my program? C control V. I have got something like this. I'll remove this part. So do you have any questions for this thing? So obviously this one I'm actually not writing. So once you have got an array of basically variable, an array of values, you can do anything what you want to do. Okay. So do you have any question for this? So this is the way of basically allocating a one-dimensional array. I'm not getting into how to work with two-dimensional arrays. The two-dimensional array, Kushal had sent me a program of by last day for the solution, right? For a C program, if you want to basically check it up, that is basically how you have basically created. It's an array of pointers, and each pointer is basically allocated to an array one-dimensional array, right? So that is basically how you create a two-dimensional array. Also, dynamically you can create a two-dimensional array. So it's basically an array of pointers, and each pointer points to another array, right? So if you want to read you have to allocate first a array of pointers that will be a pointer to a pointer, and then to each pointer variable you have to basically allocate another pointer which points to a array. And when you deallocate it, when you free the memory, first you basically free the memories of the of each row, and then you free the array of pointers. So that is how we actually go about. Okay. So I'll remove this part then. Okay. So if my argc is equivalent to 1, then file copy stdin to std out. So if I do not give any parameters, then it will be basically a simple whatever I type into it, and it will basically go to the type out, right? Else file copy fpr and fpw, right? So now there are modes for each writing opening a file. So the modes for opening a file, one is a read mode, R. So mind it will be in single quotes, okay? So this is basically only a read mode. Then I have got a write mode. So if file does not exist, it creates a new file. If file exists, it overwrites the old file. And there is the other one, what we see to be as an append mode. So append mode is that if it creates a new file, if it overwrites the file pointer points to the end of the file, right? To the end of the file. Okay, to the end of the file. Where it can. So these are the three modes. Okay. So fpr is equal to, the command is fopen. So the command is man fopen. So fopen basically it's a path name, it's a file name, and in the mode in which you basically write. So it's basically character pointer, right? So fopen, that will be basically argv1 comma argv2, right? Sorry, this will be in the read mode, right? By the way, did I basically wanna tell you the switch case? Hello?
Yes, sir.
Switch case pori diyechi? Hello?
Yes, sir.
Yes, sir.
Let's play this game like this. Switch argc, right? So it's basically, my pointer is basically this thing. I'm basing my switch is based on something like this. So switch is basically case case 1. So it's only the case is 1, then this is what actually happens. So Control X, Control V, break. Case 2, ARGV 1, and the default is okay. Any question? Have you got it? So if it's only 1, that means only the a dot out is there, only the file program name is there. So the standard will be basically whatever I write inside, it will go out. Okay. If it is only, or there is only 1 argument, right? So if it's, so I'll assume that the argument will be only for reading. It will be only for reading. And sorry, this one will be sorry. This one will be FPR. Yeah. So it just reads the file and it just outputs it on the screen, right? And the other one is basically redundant. So FPR will be FPR equals to, let's do one thing. There will be a problem over there. So this is not a big problem. PR equals to F open and ARGV1, comma, in the read mode. Okay. And this one will so I'll just make my life a little bit easier. C, Control V, Control V. So FPW. Let's say I actually basically given FPW. So let's say it's basically an append mode, right? So to keep it safer, so if there is a file existing, so it won't write it up. So you'll just basically just append it out of there. Any question till here? Hello? Hello? Hello?
Yes, sir.
Okay, now let's get into the program. File, copy. File pointer F read. File pointer F P write. Okay. Okay. What I will assume right now is basically I'm going to just read the data, right? I'm just going to read the data, and I'm going to basically just write it out. Okay. This program will not be possible if I actually give mm, if I give an stdin, so it's actually a file. So I just take the file and just rewrite it out. Okay. Um, while if p read is not equals to EOF. So EOF is basically the end of file, right? So I keep so I give basically fp read. So it just reads a file and just writes it over there. So there are some commands basically to so this is basically if. So all those commands, if you remember, that is a scanf, getc, right? Get s. So all those programs write, it is the same thing. All those commands remain the same. It's only that what happens is that it's just it just basically the letter f gets added over there, and we pointed to a variable or pointed to the file pointer gets added to it. Okay. For example, so if I give man get c, so you see this is what that. So get c was basically it was this thing. File stream, and again file, this fgetc is basically this reads from a file. This is also reads from a file, but then this was basically if I did not give anything over there is equivalent to if I did not give it anything over there, get see if it was nothing over there, then it was assuming that it was getting it from the other one was basically getchar. So getchar was void, right? We were using getchar, I believe, so as before that. So getchar was that to actually read in one character at a time from the stdin, right? So what we're going to do is basically we're going to read in one character at a time from fgetc, right? Using fgetc. So for this, what we are going to do is basically the command is fgetc. So so scar, it again basically reads a file only, reads correct if car, right? So if car is equal to f get c, it returns takes in the file pointer. So f p read, and I've got another command, man put char. So you see there's a put char which actually reads in, and there is also something like a put char f put c, right? I'll get into this part later on. So I'll just do one at a time. So f put c. So f put c will be over here. So f put c, what it takes in, fchar and where you want to write into fp write. Okay, so let's see if it basically works or not. GCC file. Oh, sorry. Well, if it is not a PDF. Wow. Okay. So read file for reading, reading and writing. Plus, so I was right. Okay, it was in a double quotes. Okay, my mistake. It will be in a double quotes. It will be in a double quotes. So this one will be in a double quotes. Okay, the present pointer in integer. Okay, there is a command by the name of end of file.
So can you please show the program once?
Just FUF. Okay, FUF. This one will be FUF. Yeah. So FUF basically retakes in the file pointer and checks to see whether it's basically file, it's an end of file or not. So this is a command. So FUF, it reads in the basically making it a mistake of basically UF because but UF is basically reads an integer. So the error which was actually coming in, I was basically comparing a file pointer to an integer, which was actually wrong. Okay. Okay. So can have a look at this thing. Any question here? Okay. So let's see how it actually looks like. No parameters. Stdi in, stdi out. Okay, so there was to be supposed to be something like this over here. Okay, let's give another parameter. A dot out, I read in basically, let's take for example this program only. Let's say for example uh, int array.c. Okay, int array c. Good. If put c, if it's supposed to be something. Let's say this is a dot text. So ls, I should be having a dot text. So uh, a dot text does exist. So let's see what dot a dot text actually basically has. How is it so that there is nothing? Int array dot c. Where was the problem? Okay, why not UF? Okay, so so you see, so the output is basically over there. So a dot text does have something right now. So a dot text. So the a dot text, the data has been copied over there. Okay. The other one is basically where was the copy? File copy. Okay, so let's do something like this. Right. Then a dot out. So there was nothing over there. So now I give anything. So A, B, C, D, this thing. So enter. So you can see basically puts is basically if you remember the past experiences of working with a put C, right? So whenever I was giving an enter, it was basically printing the whole line again, right? So Control C. The other one will be, let's take for example, it just takes in just let's say a dot text, right? So if I give only one single parameter, it will just print out the whole data on my screen only. So we have got this thing. Okay, so whatever program which I actually basically give it, so this is basically maybe this same one, file copy, right? So it just prints it this whole program only. Okay, any any problem with this thing, anything to be done? There was this mistake, while not, it should have been a while not UF. Any question? Any question here? Hello. Hello.
Yes, sir. Yes, sir. Yes, sir.
তোদের কি মাঝে মাঝে হুট করে ঘুম ভাঙে নাকি?
না না স্যার, অ্যাকচুয়ালি একটা প্রোগ্রাম দেখছিলাম, মানে রিলেট করার চেষ্টা করছিলাম একটু।
Look, if you go on basically seeing 5 programs from the internet, there are a vast lots of resources. But presently, what I'm actually basically teaching is the way of programming, the experiences of programming which I did. So it will not match with most of things. The things will not match. So you will have a lots of problems. You try to basically mix and match with your the data what you want to work with over there. Okay. Okay. So now let's see if I. So this was basically working with a. But they basically just I was reading a unstructured file. So let's say right now I'll basically take in a structured file. Okay. So this is something like this void file copy. Structured file. I take the same thing. Okay, so this is structured file, right? Okay, so this parameter will be taking something like this. So I'll assume. So this is my assumption. Assumptions. So it will be basically the program name, then file type. So that means if it is a 0, it means will be a structured. 1 will meet unstructured. Okay, and then I'll be having file name 1, file name copy, then I'll have file name right. So this is there. So I'll be taking 3 parameters, right? Okay, so that I'll be having 2 parameters as the file name as in the previous. So what I'm going to do, I'm just going to add one thing extra. So that is, it will be either a 0 or a 1. So if it's a 0, I'll mean that it will mean structured file, and if it's basically a 1, then it will mean that it will be an unstructured file. So so this one will happen then if argv one equivalent to is a 0 1, then I can basically do this thing. Right. Else so I'll be having 2 structures then. So again, this one will work out. So this one will be a 2, right? So this one will this is basically there is basically it's no use working with a case 2. So there will be no STD and STD out, right? What I can actually have only basically a case 3 only. So this one will be case 3, right? Then I will be having case 4. So case 4 is similar to this one. And this is basically printf. Sorry. Wrong parameter. Wrong number of parameters. Okay. And I'll go with the next one. So this one, I'll have a break over here, right? And this one will be a file copy. Structured file. Okay. So let's see. This remains almost the same. Okay. Now I have got some structure. I'm looking at some structured fields. Okay. There is another way of basically working with unstructured file also, right? I'll get into that later on. But let's get into basically the structured file. So the structured file, I'll assume that my data is something like this. So case 2, case 4. So my data will be something like this. Let's see. Control N. So it will be 1. Say 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right. So I have structure structured file text. Okay. So what I'm looking at, so I don't require this part right now. So I'll require rather. So since I know all the number of variables are total number of parameters in this thing is how many? Is actually 4. So and they are all integers. So like this. So int numbers 4, right? So number 4. So right now what I'm going to do is something like this. So this remains as the same. So f scan f. So this is something like this. So f scan f, what I'm going to do, I'm going to read it, right? F p read. So your scanf was totally insert. So this now parameter will look like this. So these are integers. So percentage d. So I should be knowing my parameter as the structure of my file. So this one will percentage. So this is a semicolon. Percentage d semicolon. Percentage d semicolon. Percentage d semicolon. So there is a, but at the end of the day there is a slash n. Right. So there is a slash n after this thing. So this is what I'm actually looking forward to, right? Now, what I'm going to read, ampersand of number 0. This is 3, this is 2, this is 1, right? And I'm going to just print it, printf, f printf. So f p write, comma, Control C, Control V. So number. Right. So if this file had been basically only with a space, so in case of this with this had been a space, so it could have been even a structure. So basically it can be two parameters, two values can be separated with. This could have been a basically comma, semicolon. This could have been a comma. This could have been a space. So accordingly, this thing will actually change. So accordingly, this thing will actually change. Okay. So this had to be in a comma, then this will have a semicolon, and then this had to be a space. Okay, so I believe I am actually in the right way. So let's see. Oops. There is a problem here. What was the problem? Oh yeah. This is the problem. So one was basically one is a structured, sorry, 0 is a structured, right? So 0 is a structured. Okay. Okay, then a dot out. So the first parameter will be a 0. Then what name of that thing? Structured file. Right. So what I'll do is I just print it on the screen. Oops. FPR case 3 FP read So I was actually right in the same way. Did I actually give this thing? FPR, FPW. How we? Okay, there is a mistake. Sorry. So this is 2. This will be 2, and this one will be a 3. Okay. So yeah. So I'm there. So let's say I want to basically do something like this. I want to basically keep it with spaces, right? So I want to print it with spaces. So this one will look better, I believe so. Okay. So I can have, so this was basically about writing structures. So if I had basically written in the, so if since there's no fourth parameter over here, so by default the output will be on the std out, right? Then if I had given a file over here, so it will have to open over there only. So if I had given like something like a.text, right? So and if you actually have, so this one will be a.text. So if you remember, this one, what I had done was basically I had opened it as a this thing as an append mode, if you remember. So this was basically an append mode. Okay, so whatever it actually was basically written, it was written after this file, after this data. So that is after this data. So this is basically after this data. Okay. So there was always some something which was present in the a.text. So after this data is written. Okay. All about fscan, fpair. You can have a look at another file that is a this is the same thing, man. If get if remember basically the fgets. So fgets is basically reads in a stream of into a character pointer. So it's basically what I will be doing is I'll be reading into a I'll be reading into this is another way of basically working with your this thing. So let's take for example, if I have, I'll just give an example for this one also. Version 1. Version 2, right? So this one was all about my version 1. So let's go to the version 2. So what I'm going to do is basically I'm going to create a buffer, right? So this I can actually have something like hash define, say buffer. So maybe it will be basically, let's take for example, what do you say, 32, right? So version 2 is basically buffer, right? So this one will be if gets with the fchar so to the buffer, to the array location fchar 0, then it will be the same thing as my integer size. So what is the maximum size which I can actually take? So this can be something like, so the buffer was, so this one will be by buffer. That is the maximum number of characters which I can read. And what my F stream was F write, F pre read, F pre read, right? And this is basically F put S. So F put S was basically is my, again my, so F put S is basically my man put S. Sorry, F put S. So if you actually see this cost content, this is file stream which I want to write into, right? So this one will be my character string, character string, it, and if period. So, but the other one is basically gets for your normal reading. Okay. So this one you can basically file compare. So v2 v2, right? So let's see, I'll be reading into this thing. So I have something like this. Okay, so file copy. Sorry, there was a mistake over here. Where was I? File copy. Let's go version 2. Let's say. Right. Okay. A dot out. So I'll just take in one file. Maybe let's say, for example, maybe say. So let's say this one which I'm actually basically write. So file copy. This is the one which I want to basically write, and this one will be basically unstructured file format. So unstructured format means it will be one, right? So it will be one, and what was the problem? F gets okay. Okay, there was something like F puts, right? And F puts is basically file stream. Okay, I believe I'm right. Okay, so your assignment will be basically to debug your version 2. Okay, so version 2 is not try working. So your work is any question till here, file programming. So version 2 is basically something which you have to see. There's a slight bug over there. Please check the bug. So your assignment is basically to check the bug for version 2. Any question here? Hello?
No, sir. No, sir.
Okay, so I'll end my class today for this thing today only. So I'll end the class today, okay?
Thank you, sir.
Thank you, sir.
By the way, your file handling programming is actually finished off. So this is all about file handling. This is all about file handling. So there were two modes: the structured mode and the unstructured mode. So the unstructured mode, you can use a fputs, gets, fputs, or the fcar, fget, fputc. And for a structured file format, you can basically do it something like this, for which I was actually looking for. And this is basically your total number of modes which you can actually work with. So these are we have also discussed in this way. Actually, we have also discussed your command line interpretation or command line programming also. Right. So the command line programming, rugged arrays, it's almost complete. It's actually completed. So there's nothing more to discuss over here. Okay. Chalo.